The branch of chemistry that deals with the study of coordination compound or coordinate compound. Coordination compound. Okay, is known as coordination chemistry. Okay.
Yes, sir.
Now, some of the important terminology associated with the coordination compound terminology. Because you have to say different terminology. Okay. So the coordination compound is written like this. If we take example of coordination compound, it is somewhat written like this. Cu NH3 twice, then NH4, 4, and this is a SO4. This is an example of coordination compound. Okay, we will study all the things, naming everything. So in the coordination compound, what is in the coordination it consists of a central atom. This is your center. Coordination compound, there is one central atom. This is the central atom. This is the central atom. This is the central atom. Central atom is the atom which is going to be in the center and which is going to form the bond with the anions. Okay? Okay?
Yes, sir.
Then and this central atom is surrounded by anions. This central atom is surrounded by anions. Is surrounded by anions. So basically the central atom, so what you know, basically the central atom is positively charged and it is surrounded by anions. So this is a anion, this is a ligand and this is anion. Okay. So either it is surrounded by anions or neutral molecules like NH3, neutral molecules. Okay. Neutral molecule. Okay. So central atom, this is the central atom, and these are the NH3 is known as ligand. It is a ligand, it is neutral. Basically ligands are neutral, and then SO4, it is a anion. So central atom is surrounded by, so in case of coordination compound, same thing, coordination compound consists of both. So we have studied three types of, we have studied two types of compound. One is known as ionic compound, So in ionic compound, we have positive and negative charges. Okay, these are found between metals and non-metals. Ionic compounds are found between metals plus non-metals. That is your ionic compound. Okay. Now, second compounds we have studied about covalent compounds. So covalent compounds are basically have covalent bond between them. They have ionic bond. These ionic compounds have ionic bond between them. Yeah. Okay. Then covalent compounds are the compounds that are formed, the compounds that form covalent compounds are the compounds in which the covalent bonds are present. First, there are covalent bonds are present. And second, they are formed between non-metals. They are formed between non-metals. There is no metal involved. So these compounds are formed by sharing of electrons. Okay. Now, when we talk about the coordination compound, it is combination of both the things. In this coordination compound, there is ionic bonds also present. Ionic bonds are present, and Covalent bonds are also present. And covalent bonds are present. So both the bonds are present in case of coordination compound. Got it?
Yes, sir.
Yeah. Written?
1 second, sir. Yes, sir.
Done? Can I raise it?
Yes, sir.
Okay. Now. Okay. What? What? Okay. Now. So first terminology associated with the complex ion. First is your complex ion. Complex ion. First is complex ion. Like I have taken example. I have taken example as Cu NH3 and it is 4, then SO4. So complex ion are the ion that is electrically charged. First, these are electrically charged. It is electrically charged. Then this can be positively charged. This is positively charged. Or negatively charged.
So have you looked at the portion which I sent you to make sure, like, to see what you're doing is in the syllabus? I sent you the syllabus already.
Yeah. Give me 1 minute. These things must be there, because if you do not know the terminology, all the things, you are not able to do the coordination compound, because this is the starting, this is introduction part. Okay.
Okay, sir.
These must be either it is given or not, you have to study. Okay, if you are not able to, because these are the basics. Yes, surface chemistry. No, you have the coordination. Coordination. So it is coordination about coordination. Okay, introduction. Yes, ligand. Yes, ligand, number, magnitude. Yeah. Okay, I have got it. Okay.
Okay, sir.
So what are complex ion? Complex ion. So in coordination compound, there is complex ion, and complex ion are electrically charged, or it may be positive or negatively charged. Okay. Okay.
Yes,
And in this, a central atom is there. A central atom is there. Atom is there, surrounded by neutral or negative charge, surrounded by neutral or negative charge. So complex ion. So this is the complex ion. This is the complex ion. This part of the coordination component. So here, this part Cu NS3 4 is a complex ion. So in this Cu is the central ion. Cu is the central ion, and it is surrounded by 4 NS3 molecule, which are neutral in nature. Okay, and this ion is positively charged. This is +2. So because sulfate has -2 charge, sulfate has -2 charge, so it will be having, because whole coordination compound whole charge is neutral, so it must be having positive charge. Got it? So this is called,
Yes, sir.
the molecule that are present, the ions that are present inside the bracket are known as complex ion. So it is always present inside the bracket written, and it must be positive charge, negative charge, or neutral, or and what is the complex ion? Complex ion, there is central atom surrounded by neutral or charged particles. Okay, got it?
Yes, sir.
Then next is, can you rub this?
Yes, sir.
The next is your ligand. Right. Do you know what are ligands?
No, sir. Could you explain it?
Yeah. So these are the neutral molecules. These are the neutral molecules. These are the neutral molecules, and that surround the central atom, and it surrounds the central atom. Surrounds the central atom. Central atom. Okay. In a complex time. So what I have written, this is your Cu NS3 4 and SO4. So this part is a complex ion. I have told you this part is a complex ion. So it is a complex ion. Cu NS3 4 raised to power. Okay? This is complex ion. In complex ion, this is your central molecule. This is central atom. Then this central atom is surrounded by this. This is your NS3. These are neutral molecules that surround the central atom. So this NS3 is a ligand. This is a ligand. Got it?
Yes, sir.
Yeah. Ligands are further classified as unidentate ligand, then bidentate ligand, then your tridentate ligand, then your tetradentate, then your hexadentate. Hexadentate. Hexadentate ligand. So what are unidentate, bidentate, tridentate, tetradentate, hexadentate? Basically, these ligands are classified on the basis of presence of donor site. Presence of donor site in them. For example, if I've taken, this is the central molecule and this is the NH4, NH3. NH3. This is NH3, this is NH3, this is NH3. So there are four molecules attached to it. There are four molecules attached to it. Okay, you got it?
Yes, so therefore, yeah.
No. So four molecules, and each has one donor site. Each has one donor site. Okay, got it? Each has one
yes,
donor site.
okay.
So it is unidentate. It is a unit. So this is the ammonia, one donor site, one donor site, one donor site, and one donor site. So it is unidentate. It is unidentate. Got it?
Yes, sir.
Yeah. If it is, so if the donor site is 2, if donor site is 2, then it is known as bidentate. So unidentate, one donor site, one donor site. Bidentate has 2 donor sites. Tridentate has 3 donor sites. Tetradentate has 4 donor sites. Hexadentate has 6 donor sites. 6 donor sites. So on the basis of donor site, ligands can be have 1 donor site, 2 donor site, 3 donor site, or 4 donor site or 6 donor site. For example, bidentate, for example, this is the example, amine. Amine is the example of unidentate donor site, then bidentate. When we talk about ethylamine, CH2, NH, this is the ethylamine. This is also act as ligand and it has 2 donor sites. It is because from one, this is extra electron, this is extra electron, so they have 2 donor sites. So this is known as bidentate. So this is known as bidentate. Okay? Clear? Okay?
Yes, sir.
Ethylamine has 2 donor sites, so it is known as bidentate. So if we write a structure, okay, so ethylamine has 2 donor sites, so it is bidentate. And if you write if I can write a structure, so yes, if you write a structure, so one example is that Cu CH2 NH2 twice. This is a complex ion. So this is copper. This is copper. So here, so this is your ethylamine. So this is CH2 NH2 and this is CH2. So this is the structure of methylamine. One methylamine to this side. So it has 2 donor sites, and so it has 2 donor sites, and this one second methylamine to this side. And has 2 donor sites. So this is the first donor site first. This is 2 donor site and this is 2 donor site. So this is bidentate ligand. Okay, got it?
Yes, sir. I will just write it down one second.
Yeah.
I should note down both of the examples, right?
Yeah, because the examples are very important.
Okay, sir. So what are the names of these compounds? Is it
Naming,
important to remember that?
Yeah. So naming, I will tell you because it is important. First, you remember the terminology. Then, according to the terminology, you will study the naming. Okay, I will come to the later part because if you do not know the terminology, I just name it and you will get confused. Okay. So each and every part I am going to explain it deeply so that there is no confusion coordination compound.
Okay, so done.
Yeah. So ligand. So first we will talk about the ligands. Okay. So these two examples are very important. Then when name will come, I will tell you what about tridentate and tetradentate and hexadentate. Okay.
Okay, sir.
Okay. So these two examples I have told you. Then so the ligands are also known as chelating agent. What do you mean by chelating or chelating agent? They are ligands are also known as chelating agent. What do you mean by chelating agent? Do you know what is chelating?
No, sir. Could you explain?
Okay. Not all the ligands act as chelating agent. Only multidentate ligand. Multidentate, like by tridentate, tetradentate, multidentate ligands act as chelating agent. So chelating means in Greek
So
what it
even
means
bidentate
flaw.
is
Yeah, bidentate also.
okay.
So chelating means flaw. In Greek what is flaw? Flaw means they hold the central atom. So this is your, so this is methylamine. This is the, I have told you this is bidentate. So they hold the central atom like forming a ring. They surround the multidentate, so they form a protective covering around the central atom. They form a protective covering around the central atom, and this is known as chelating property. Okay, got it?
So could you explain it once again? I don't
Okay.
understand.
Okay. All the like multidentate. So every central atom is surrounded by ligands. Okay. If ligands are multidentate, they form. So chelating means in raw it means claw. Claw means to hold. Okay. Claw means to hold. So they hold the central atom from multiple sides, and they form a ring-like structure around the central atom. So they protect the central atom from further reaction. Okay. So basically they act as protective. The protect. So that is the protecting nature of the compound by forming a multiple bond to it is known as chelating property. Okay, got it?
Yes, sir. Got it.
So what are the main properties of chelating? When they surround the central atom, they form a more stable compound. A chelating, the multidentate ligands form a more stable compound. Chelating, or we can say chelating ligands form a example part is a chelating ligand form a more stable compound than non-chelating ligand. Non-chelating ligand. Okay, got it?
Yes, sir. So what is it after more stable?
Compound.
Compounds, okay.
Okay, written.
Yes, sir. Done.
Then second property of chelating agent is all bidentate, tridentate, but all the multidentate, tetradentate, hexadentate forms chelating agent. Okay, tridentate, bidentate, tridentate, tetradentate, and hexadentate forms chelating agent. Okay. Then very important property, third property of chelating agent.
So what's the last point you wrote?
All the non-chelating, sorry, all bidentate, tridentate. Okay, I have told you that all the bidentate, all the multidentate. Multidentate includes bidentate, tridentate, tetradentate, hexadentate forms chelating agent. Okay. Okay. Next. Okay. Then written, you have written.
Yes, sir.
Okay. Next point is that the larger ligand forms a unstable coordination compound as compared to the smaller ligand. So more larger the ligand, the more unstable the compound is. The smaller the ligand, the more stable the compound is. Okay.
Okay, sir.
So some of the common example of, I am giving some of the common example of ligands. So example of some of the common example of ligands, according example of ligand and according and with their nomenclature. Okay. So first is ammonia. This is very commonly used. So most of commonly used ammonia. This is frequently used. Like ammonia. Ammonia. The formula for ammonia is, you know, that NS3, and it has charge. Very important. So this is name. You can write the table name, formula, then charge, or then your name of ligand. What is name is given a name of ligand. Name of ligand. Okay. So this is how we can. This from here your nomenclature started. Okay. From here your nomenclature started. Okay. So ammonia formula is NH3. It has one lone pair of electron. Charge is 0, and it is named as amine. The ligand name is amine. Got it, Niklesh?
Yes, sir.
Second is your water. This is your hydro. Charge 0. And this is known as aqua or aqua. Got it?
Yes.
Third is your halide ion. means chlorine, fluorine, bromine, iodine. This has formula. This is minus. This is minus charge, so it has -1 charge. These things you have to remember. And this the nomenclature is halo.
So that's minus X, right?
Yes, minus X, and
Halide.
they have two,
Okay.
one lone per electron. Okay. This can be anything. This can be chlorine also, bromine also, iodine also. Okay. You have studied all the things when we are studying in organic chemistry. Okay.
Yes.
Then next is hydroxide ion. So this is OH minus. So it is -1 charge and it is known as hydroxyl. Hydroxyl. Okay. Written?
Yes, sir.
The next is cyanide ion. Cyanide. So this is CN -1. This is -1 charge, and this is known as cyano. Cyano. Okay. Can I rub it? All of it?
1 second, sir. Yes, sir.
Okay. So next is next example is oxide ion. Oxide ion. So oxide ion is O -2 minus. So they have 2 minus charge, -2 charge. And name of the ligand is oxo. The next is your peroxide ion. Peroxide ion. And it is O2 O minus, so it has -1 charge, and it is known as peroxo. The ligand is peroxo. The next is your carbonate ion. बारिश नहीं हो रही धूप निकला हाँ -2 and is carbon. This is known as carbonato. This is carbonate. Okay.
So, what is carbonate ion called?
CO2 CO3 -2.
So, what is the name of the ligand?
This is carbonato. Carbonato.
Okay, sir.
Then for some of the positively charged, then some of the positively charged example I am giving, that is nitronium, nitronium. So it is NO2 plus charge. So it is positively 1, and its name is given as nitronium. Nitronium. Okay.
Yes, sir.
Then last I'm just giving you the name. So this is amide. So and all other names when it came when the nomenclature when it comes, I will tell you the name. Okay. Amide, it is -1, and it is amido. Amido. Okay. Amido. Got it? Written? Can I rub this? Yes, Niklesh. Niklesh, are you there? Okay.
Hello, sir. Can you hear me?
Yeah. Okay. So I'm going to take your class on the whiteboard. Okay. I'm just okay because it is take. Okay. Join me on this. I am changing the link, meeting ID. Okay. So just
Okay, sir.